All right, let's take a look at the bell work here. The first two, all we're worrying about here is factoring out of GCF. Okay? So, greatest common factor. What's the biggest number that goes into 4 and 12? 4. So I pull out a 4. Any variables? X. So, what do I get in the parentheses when I factor out a 4x? X plus 3. And how did I get x plus 3? What did I end up doing? Yeah, what I'm doing is I'm dividing each one of these terms by my GCF for 4x. Okay? Also remember, if I multiply backwards, then I will get my original answer. All right, or distribute it. All right, what about number 2? What's my GCF there? 2. So I factor out a 2, and what am I left with? Okay? Now, where we're going to get to, and we're not there yet, but where we're going to get to is our next step then will be to ask yourself, is it a binomial, a trinomial, or a 4-term polynomial? And what is this? It's a trinomial. So now, when I factor a trinomial, what is always my first step?
First time last, add to the middle.
First time to last, add it to the middle. Now, so this one here doesn't factor, and I gave you one that didn't factor on purpose. All I wanted you to do is factor out the GCF. Okay? But understand, after you factor out the GCF, that's when you go down one of the paths, binomial, trinomial, or 4-term polynomial. All right? Now, with that in mind, though, let's look at number 3. All right, so let's factor this trinomial. This is going to lead us directly into today. Okay? What's always my first step? GCF. GCF is always my first step. Is there a greatest common factor?
Yes.
No,
there is not. Sorry.
No, there's no GCF. There's no number or variable that is common in each one of those 3 terms. So once I get through the GCF, I have to ask myself, is it a binomial, a trinomial, or a 4-term polynomial? Trinomial. It's a trinomial. So I know because it's a trinomial, what's my first step?
First time to last, add to the middle.
First time to last, add it to the middle. So I'm going to take the first number times the last number. Now my first number is 1. It's not x squared. We're looking for the coefficient here. So the coefficient is 1. So 1 times 10. So I need 2 numbers that multiply to give me 10, but add to give me my middle term. Remember, first times the last, and it's got to add up to the middle. So I need 2 numbers that will multiply to give me my first times my last, but add up to give me my middle term. First times the last, add up to the middle. Now, negative step. Yes.
So, why you got to multiply the first one? You add up in the middle and multiply.
It's 1 times 10, which is 10. So you need 2 numbers that will multiply to give you 10, but add to give you your middle number, which is negative 7.
Okay, so you want the first and last number, when you multiply, they equal that one.
Yes. Yes. We'll go over more of it. We've got a whole lesson on it still. All right? So first times the last, add up to the middle. Now, so I need to find 2 numbers that multiply to give me 10, but add to give me negative 7.
5 and 2, 2 and 5. Negative 5.
Yeah, negative 5 and negative 2, right? It's really important that we have our signs right. These numbers do have to be the same. They can't be 1 for the top and a separate group for the second. We're finding 2 numbers that multiply to give you positive 10, but add to give you negative 7. Negative 2 and negative 5. Now, is my coefficient 1?
Yes.
If my coefficient is 1, then I am done. Done. So now, what that tells me, then, is this. I'm going to write, it's minus 5 and minus 2. So I'm going to write x minus 5,
X2.
x minus 2.
X squared.
It's not x squared, it's x. It'll just be x. again, this up here, if I look up here at 1 and 2, this is factoring out the GCF as the opposite of the distributive property. Factoring out a trinomial is the opposite of the double distributive property, or FOIL. So if I was to double distribute here, I should get x squared minus 7x plus 10. Questions on this? All right, so let's take a look up here at number 1. All right, if we take a look up here at number 1, all we're going to do here is just a double distributive property. So I'm just going to multiply these two out. So I get x squared plus 6x, and then I multiply both by 3, so plus 3x plus 9. I'm sorry, plus 18. Again, these two middle terms usually simplify, so I get x squared plus 9x plus 18. Again, remember, if you guys look at this, you guys can kind of see the correlation here because of what you already know. Think about, if I factor what I have here in black, I know that I'm going to get this. So understand that when I first times the last add up to the middle, so I need two numbers that multiply to give me 18. Why? Because of my last step. 3 times 18. That's how I got this number. So I need two numbers that multiply to give me 18, but add to give me 9. Why? Because of this. These same two numbers will give me 6x and 3x, which add to give me my 9x. That's why it works. That's what we're doing. Okay, does that make sense? That's what's important here. If we look at number 2, we get the same thing. I get x squared plus 6x minus 4x minus 24. And you can kind of see again how the signs change, how that might affect it. In this case, I get x squared plus 2x minus 24. And the same thing. How did I get to 24? Well, negative 4 times positive 6. I need two numbers that multiply to give me negative 24, but add, when I add them together, when I get the 6x and the minus 4x, I need to add to give me positive 2. Does that make sense? That's where we're going. That's how you do the opposite of the double distributive property. You have to understand those principles. Okay? So again, we already have in our schema here, that a trinomial, always, our first step is what? First times the last, add to the middle. What is it?
First times the last, add to the middle.
I need two numbers that will multiply to give me my first times my last, but add it up to my middle number. So if I look at this first one, letter A, all I'm looking at is the first times the last. So I need two numbers that will multiply to give me 6, but add to give me 5. So I hear 2 and 3. I also hear 6 and negative 1. So let's